and welcome. Enterprises are collecting more data than ever. And the question you have to ask yourself is how much of that data is actually being used to provide value to the business? The unfortunate answer is not as much as you would hope. This has become such a big problem that people have actually given it a name. It's called dark data, and it represents a big missed opportunity for business and also some risk. Now, at the same time, we're at an inflection point in the industry. Generative AI is providing opportunities for companies to take advantage of more of that data, and it's driving them to want to solve this dark data problem. Hello, my name is Dave McCarthy. I'm a research vice president at IDC, and I've been studying the dark data problem for some time. I'm joined today with Asad Khan. He's a senior director at Google Cloud, who's on the front lines of helping customers with this dark data problem. So Asad, welcome.
Thank you, Dave. And it's a pleasure to be here. And this is a topic which I'm super passionate about, and especially being in the Google and Google Cloud, we see a huge opportunity ahead of us.
Well, great. So we're going to do a couple of things today. We're going to start off about defining the scale of the dark data problem, and then we're going to move into an AI-powered solution to help people overcome this. So let's start with the basics. Like, what is dark data and what is the scale of the problem? If you think about it, for so many years, enterprises have been told that data is their most valuable asset. And IDC has been looking at quantifying how that data has been growing and what people are doing with it. So according to our research, enterprise data is growing at approximately 29% a year. And 85% of that data is unstructured, which creates different challenges for customers. But even worse, if you actually look at the usage of all of that data, most analysts agree that about 95% of it goes unused once it's stored. And so think about the universe of what companies are looking at. They're looking at the documents that they use internally, things that they collect and process from customers, more often now video and graphics and other sort of unstructured data. You know, all of this means that they're storing a lot of data. And while they're getting some value of it, they're not getting all of it, right? And so some of this becomes the petabytes of information that they're storing and the cost that goes along with it. And if you're not able to extract the information that you want out of that, then it's kind of like you're getting all of the cost and all of the risk without any of the reward. And I have one just personal example. I spent a bunch of time in the IoT space. And what was great about that is at that time, it was a new way of collecting new sources of data. So all these smart connected devices had this great promise. And companies invested a lot in terms of trying to figure out how to instrument that data, how to collect it all. But the unfortunate part is, in the end, they didn't really get the value that they were looking for. And it's because of the dark data problem. That technical debt that was associated, in some respects, just added on to it. And that's why it's just so important that companies figure out ways of solving this. So Asad, what are you seeing within the customers at Google Cloud?
Yeah, so this, you exactly pointed out the right thing, which is that we see that especially as the cloud storage advanced in terms of the low cost storage space with lot of durability and reliability, and the smartness in terms of as the data is stored for a long time, it moves automatically into the archival tier, which is even cheaper. Customers and enterprises start to store every bit of data that was being generated. And IoT is a great example where there is an IoT device everywhere, whether you are at home or whether you are driving in your car or whether you are in an enterprise running a factory. But when we look at how much of that data is analyzed, it's a very, very small subset. And the same is true for even if you are a healthcare company. You have medical records, you have images, and you upload all of that and you are scared that, I should not delete anything because there might be some insights in it and I can drive and grow my business based on those insights. And all of that is true. But when we look at how much of it is actually analyzed, it's a very small percentage. And in order to understand that problem, we have to go back in time and understand that the data has always been very, very powerful and useful for enterprises. And it started from the databases. Although databases were not built to store the data, it was to power your applications. But the databases were built by the design that you define schema on write. And since you have the schema, or think of it, the metadata describing the data itself, it makes it super easy to now understand that data. And then on top of the databases, you have powerful languages like SQL, which you can exactly query and make sense of that data. Now, if you fast forward in the cloud, as the storage systems were built and people started to store more and more unstructured data, that data was not being analyzed. So in the early 2000s, we saw the analytics or scale out systems being built where you can do schema on read. Now you had a powerful tool. You can store a lot of your data in an unstructured format, and whether it is CSVs, PDF, or images or videos, and then you can define the schema and then make sense out of it. The problem with that is that it involves a lot of human interaction, because now you need someone first to decide which data set is interesting. And once you have decided that thing, you need to do some data cleansing. You need to get it in some shape or form. You have a pipeline. You have data engineers whose job is to do that as the data lands. And only after that you can run some sort of analytics or query on top of that data. It is still a huge breakthrough, and we still see that the amount of data which was being analyzed exponentially went up. But when you look at the entire set of unstructured data in the cloud and how much is being used, it is still a very, very small percentage.
So it sounds like you're hitting on the scalability problem, but not in the way that everybody thinks about it. Sometimes people talk about scalability like how much data can I store, like if it's a technical problem. But you're hitting on some of the human scalability issues of if you have to do all that, manually, if you have to go through and build these schemas or add metadata to the objects and things, and you have to do that on a kind of a personal, manual basis, then ultimately those resources are scarce. And most companies just can't keep up with this growing. You have this growing set of volume of data, but you don't necessarily have a growing set of volume of people, right? So it creates kind of like a bottleneck in a lot of ways. And so, it just makes me wonder, so what's the better way to do this?
Yeah. So I think that if you look at it, we all agree we are at an inflection point or the disruption in the market, which is happening through large language models. And the question becomes, can that solve the problem of dark data or the unstructured data? And obviously, large language models themselves are trained on sort of the both structured and unstructured data. So it's not that it has not been proven, but it is not being applied today when it comes to the enterprise data, because the large language models obviously scans the web and they train themselves or some other data sources which have been curated and fed through the large language models. But the data which is stored by some security company which takes videos or photos, or a medical company that stores their records, or a retail company which is just taking all the feedback from the support cases and putting it in the storage, that one is not accessible to the large language models we deal with. And the question is, can this come and solve the problem? Absolutely, but so far we have been looking at that problem in a wrong way. What we are doing, and most of the systems are doing, is that they take a large language model, they point to an unstructured data source, extract all of that information, vectorize it, and then use it in the large language model. The problem is you have the sea or ocean of that data, and you are using a straw to just take a small subset of data. Now the problem is both scale and which data files should I point my large language models to. And obviously there are a lot of methods which have come up, whether you think about RAG itself is an example where you will say, okay, I have my data, I have vectorized a small set of data and I will use it for my RAG patterns. But nobody has solved it at a scale of exabytes of data. Mm-hmm. Because when you are solving it at exabytes of data, you have to push the problem where the data is being stored rather than in an external system which can operate on that data. And there is this fine line, but it is a game changer in terms of how you can do it at scale when you are not taking any of the data outside of these object stores or the cloud storage systems, but push the problem to them. And that is where Google is looking at this thing and what we are calling at that smart storage.
Got it. So what you're kind of describing to me, and I think this is where a lot of customers are stuck, is there's this gap between this new world of AI and large language models that are generating a lot of value because all of the work and pre-training and all that has been done. And then this whole universe of enterprise data, which again is the dark data, that is incredibly valuable, also very proprietary and needs to be maintained safe. So there's this gap, I guess, between the two of those. So how are you and the teams at Google Cloud helping to bridge that gap for customers?
Yeah, I think first of all, I'm super fortunate to work in a company like Google, because in order to solve this thing, you have to do innovation at every layer of the stack. You have to have a large language model, and Google is at the forefront of it with Gemini. You need to have the AI platform, and Google has the Vertex AI. You have to have a system which can build a very rich knowledge base, and that is where the BigQuery comes in. And then you have to have a large scale storage in the cloud, which is the GCS, or the Google Cloud Storage. And what we are trying to do is, like, we are starting solving the problem at the storage level and then work it all the way up to the stack in terms of what is the customer interaction with that one. So the way we are looking at this problem is that as the data is stored, or whether it was stored 2 years or 6 years back or 10 years, how can we start to use large language models, obviously with the customer consent, to go and generate the insights out of their data? And the way it is generated is through generation of the metadata. Now it is, let me walk you step by step. The first problem that we need to go and solve is, if you have the trillions of objects and you have exabytes of data, can you build a platform which can store the rich metadata for each and every one of those objects? That itself requires a lot of investment in a scale-out metadata storage system. And it has to be right where this data is stored, which is within the GCS. The second thing is, if I feed, or the customer feed, their unstructured files, or ask that all of their unstructured data should be analyzed, can we take all of that unstructured data and generate the rich description about those files? So now you have two steps. Now you have the platform which can store the rich metadata or the description, and now you have the models that can extract that information from that. The third thing is that, can you put it in a format that it easily be consumed by the layers on top of it? And that is where the embeddings of the vector representation comes in. Once you have all those three lined up, and at the storage level, whether you are sitting in an archival layer or you are sitting in a more active standard class in the storage, now we have, in some sense, already cracked open every file that you are storing in the cloud and giving a meaning and a sense to it. Now that is where the magic starts to happen, because now you can come through BigQuery, or you can come directly through the Gemini and start asking questions about the data that you have stored in the cloud.
I'm glad that you used the word magic, because I think everyone's first experience with generative AI felt a little bit like magic until they got into the enterprise side of it, and then it didn't feel very magical at all because there was a lot of that manual effort. So it sounds like what you're describing is taking the concept of metadata generation and moving it from a manual process to an automated process. So for customers watching this today, how much of this is real?
Yeah, that's a great question. So we recently released two capabilities, which are the foundation of what I'm talking about as a smart storage, as the concept and as a product. The first one is the object context. And object context give the platform a very rich scale out at the scale of the GCS to store metadata or the description of every object which is stored in there. Now, the next question is, where does that description or metadata comes from? It can come from both from the manually from the customer themselves, but in order to make it scale at the GCS of our trillions of objects, what we have is the auto annotate capability. What auto annotate does is that for the specific file format, we use the model to generate the description. And obviously all of it is done with the right security and customer consent. And that is actually one more reason why to do it in the storage itself, because once you take the file out, you have to remember or reapply the security settings. Here it is done in place. So today with the object context, we are able to store the rich description of every file which is stored in GCS. And the second is through auto annotate, which we started with images first, we are able to extract that description. So think of it as you are a customer, and again, you being a customer, you are always in control of your data and the security of your data, because that is super, super important. Like there is a reason like the large language models have not been able to get to the enterprise data, because for good reasons, that data is owned by an enterprise and it's secured. And it is not just about the enterprise. Even within the enterprise, we want to make sure that if you are not supposed to get to a certain file or an object, you should not get to it, even if you and I work in the same company. So it all starts where the customer themselves decides that this is the set of files for which we want to fully define or create the descriptions based on that. We go and use these internal models. We generate the rich description of those files and then store it in object. And this can be done at scale, and that is where the difference comes, because some listener might be thinking that, oh, but that is not unusual. Today I can go to any large language model, I can throw some unstructured files and it can make sense. But here we are talking about exabytes of data, trillions and trillions of files, and all different type of formats. So we started through pictures, where you can take pictures or images, and we started working with a lot of two set of companies, actually, the security companies and the companies who are looking for images for training their models. And we applied this model, extracted that information, stored it in object context, and now you can reason on top of it. So think of it, all the scenarios that enables.
So do you have any real world examples of a customer that's using some of these capabilities today?
Yeah, one of the customers we are working very closely is Vivint. It is a security company. They have more than 27 million security devices installed, and all of these images are, as you can imagine, generated all the time and then stored. So they had a manual process through a lot of human interaction, building pipelines to analyze those images, and now they have reduced that from 6 months to a single month, because all of these images that they are uploaded to GCS, we do the auto annotation on top of it, store the rich description of every file which is stored in GCS, and now their developers can easily go and build on top of that thing. So that was like an eye-opening moment for not only for the customer but for us, that as you push the problem closer to where the data is stored and apply the AI models there, it can do it both at scale and it can do it with very or no human intervention. Similarly, there are other companies we are working with who are in the business of either fine-tuning the models or more of applying further refinement on the model which has already been generated, and they are looking for specific set of data. Like, for example, I want to get all the images where the cars are standing on a stop sign, or all the cars of a certain type, or all the cars which are driving on a freeway. Now, they don't have to worry about how they go and find that thing. They don't have to take the data out of the GCS. We are bringing all of those insights into the storage itself, and that's why we are calling it smart storage. So we are seeing that there is a big disruption which is happening, and Google is leading that, where the storage, which has been typically seen as a passive storage, where all it gives you a cheap and durable storage system, suddenly is super smart in terms of when you store the data, we right there can analyze all of your data without any human intervention or creating some complex pipelines of data engineers coming in and cleaning that data, and storing that rich description of your data right there. And then you can layer the other stack on top of it, as I said, whether it's BigQuery or whether it is Vertex, all the way to Gemini, and interact with your data.
It sounds like you solved a needle in the haystack problem for them.
Exactly, and I think that comes back to your dark data problem, which is that typically the problem that customer has is not only how do I reduce the effort required to analyze the data, but what data is important that should be analyzed. And if you are generating so many images, either you spend a lot of human resources, as well as GPUs and TPUs to analyze all of those images, or the way we are solving it is that all of that is automatically solved for you by generating the rich metadata and description of the images, and then you can only query through interfaces like Gemini and look for the pattern or the set of the images that you care the most.
It's clear that what you described is much more than a set of features, but really a new paradigm for how people are going to be managing their storage infrastructure. So for the people that are watching today, CIOs, the developers, the data engineers, what's one single takeaway you would like them to have, and how should they think about today's conversation in terms of their future cloud strategy?
Yeah, sure. So I would say two things. One is that this is just the start of the journey. What we are bringing is the building block through object context and auto annotate. There's a lot more to come for us to fully deliver the smart storage vision. The second thing is that so far the storage systems, especially in the cloud, are seen as a passive system when it comes to building AI applications or agents, because like the data is put there because it is a cheap, reliable place and durable place to store your data. But with the smart storage, that changes the paradigm in terms of how developers build the AI applications, because it is not only a storage layer. That layer also has a lot of intelligence about all the data which is stored there, and in the format which can easily be consumed by the AI agents and applications, where we will make sure that it is vectorized and embedded and searchable, which makes the life of the developers and even the people who are training models super easy and more effective to go after all of the data that is being stored.
I agree, it's a powerful vision, and I can't wait to see what comes next. So today we discussed the dark data problem and also a path forward for how people can think about transforming their storage into a smart, active part of their overall enterprise architecture. So Asad, thank you so much for sharing those insights with us today.
Thank you, Dave, and it was a really good conversation. Since like we share the bond in terms of the dark data and what can be done at the storage level to solve those problems. So it's a really fun conversation, and thank you for having me.
Absolutely. And thank you for watching.